Alrighty, so we finished up 1.5, 1.6, which was adding real numbers, and then I think 1.6 was subtracting real numbers. So now we're moving on to multiplying and dividing real numbers. Uh, kind of going through with a slide on the PowerPoint that I think is extremely important is um, this one right here. Let me go to my document, share the screen. All right, so this is definitely the most important. It will. Oops, sorry, fix it. All right, so this slide right here kind of reviews all of the uh, operations that we've covered up to this point. So you have your addition properties up here. Remember, if the signs were the same, you add them and you keep the sign. So if it's a negative and a negative, it stays negative. When you're adding two positive, it stays positive as well. The rule was when you were adding signs that were different, you're supposed to subtract the two and then you keep whatever the bigger sign is. That's how you know what your answer is. All right, so now down here we go to our multiplication division. Now again, these work whether I'm multiplying or dividing. So if I multiply a positive and a positive, I get a positive. When I multiply a negative and a negative, I also get a positive. So if you can remember, if the signs are the same and I'm multiplying or dividing, my answer is always positive. When my signs are different and I'm multiplying or dividing, my answer will always be negative. So it's different from our addition rules. And I know I kind of mentioned before, you got to know the difference between the two rules. You have your addition and subtraction rules, and then you have your multiplication and division rules. So we got to keep them kind of in our brains in different folders. We can't say, well, I thought a negative and a negative was a positive when I'm adding. No, that's when I'm multiplying. Yes, a negative times a negative gives me a positive. Remember, when you're adding two negative values, the answer remains negative. So those are, again, this is that slide. Like I said, it's pretty important. Kind of covers just a little kind of review of everything up to this point. So let's look at some examples that you'll see on 1.7. So you know you're multiplying here because of these parentheses between these. You do not see an operation between the -6 and the start of the parentheses here. That tells me you are multiplying these two numbers together. So what I like to do sometimes just let's focus on the sign first. What is a negative times a negative going to give me? We know that a negative times a negative gives me a positive value. So we don't normally write a plus when we're dealing with positive. We just don't put a sign in front of it. The next question is just what's 6 times 10? Well, 6 times 10 is 60. So we know that that answer is going to be a positive 60. That's kind of how you would write it. You're not really going to enter a plus. You enter that. You just leave it as positive 60. Another example, -4 times 3. Again, so we have a negative value and a positive. Anytime the signs are different, we know our answer is going to be a negative. And then 4 times 3 gives me 12. So I like to come up with what is my value going to be first, and then just multiply it. So now I'm not, once I figure out it's a negative, I'm just focusing on the numbers at that point. Let's look at some fractions. Again, you know you are multiplying because if there was an operation here, if there was a plus sign here or a minus sign here, then I would be adding or subtracting these two. But the fact that I have a number and then it goes right into a parentheses, or in this case, a bracket, this means I am multiplying. We follow our multiplication rules. The first thing, let's figure out the sign. We have a negative times a negative, so I know my answer is going to be positive. I look to see if I can reduce anything before I multiply by looking at these numbers here, and I can't. Then I'm just doing 1 times 5. gives you 5. And then 3 times 6. Again, you're multiplying straight across on these fractions. 3 times 6 would give me 18, so you get 5 over 18 in that case. Another fraction one. Again, we know we're multiplying because there is not an operation between before the bracket starts, okay? I'm just going to continue to say that. But unlike this fraction here, I can clean this up before I multiply straight across. Because 8 will go into 16, right? 8 goes into both of those numbers. 8 goes into 8 one time. 8 goes into 16 2 times. And then we have the 5 and the 25. Well, 5 will go into 5 one time. And 5 will go into 25 5 times. So you'll save yourself some work. If you don't see that, you got to multiply straight across, and then you're going to have to reduce, which is going to cause you just some more work there. All right, let's talk about our signs. I have a negative times a negative. Any times a negative times a negative, that gives me a positive value. So now I'm just doing 1 times 2, give me 2. And 1 times 5 gives me 5. Right. What we have here is, it's kind of like an order of operations problem. We got 4 numbers. If you notice, they're all going to be multiplied together. So if you think of our order of operation, how do I know which one to do first? I don't have parentheses. I don't have exponents. All these are multiplications. Hopefully you remember that you work from left to right. So we're going to work this way. And I'm going to do one at a time. I'm doing a negative number times a positive. Negative 3 times positive 4 would give me a negative 12. Then I move the other numbers down. Again, left to right. Now I'm working on these 2 numbers. But I have a negative and a negative. Negative times a negative gives me a positive. And 12 times 3 gives me 36. I move the negative 4 down. And then that is my last step right there. At this point, I'm going to go to a calculator. I know that off the top of my head. What I do know is positive times a negative, that this answer is going to be negative 144. Now, one thing with you guys using a calculator, it's very, very important that you know how your calculator works. Some calculators will allow you, say I want to do 36 times negative 4. They will allow you to put the negative sign and then change it to a 4. Okay, but if you look now, my 4 is positive. It's not negative. So in my calculator, I have to actually put the 4 first. Then I press this button down here, this positive negative button. And you'll notice it'll switch it from negative to positive when I put this, once I push that button. And I want it to be negative, and then I press equals. Okay, now some of your calculators, like I said, if I tried to do 36 and I push this, minus 4, well, it's not going to be multiplying, it's just going to subtract. So just know your calculator. Most of your calculators are going to have this positive negative button. Just on this one, again, I have to put the number first and then make it negative. All right, next thing I want to talk about is some of these exponents. I want to talk about the difference between that problem and this problem. Now, you may look at it and say, well, that's the exact same problem. And it is not. The reason being, when these parentheses make a very big difference. Okay, so since the negative 9 is inside this parentheses and then it's squared, that means negative 9 times negative 9. And we know a negative times a negative gives me a positive. And then 9 times 9 gives me a positive 81. What I want you to understand is there's no parentheses around this negative value here. So really what they're telling you to do is to do this exponent first, and then we're going to make it negative. So a good habit to get into is when you don't see those parentheses, understand this is what's going on. Separate these two. Okay, like you're taking a negative value and you're applying it to the 9 squared. Okay, and if you think about our order of operations, parentheses first, exponents come first, then multiply or divide. So we would always do this exponent first. Again, this is 9 times 9. And 9 times 9 gives me 81. But remember, we had that negative in front of it, so it's actually negative. Remember, negative times a positive gives me a negative 81. So understand that even though they look very similar, this one's a positive 81, this answer is positive 81, but this answer here would be a negative 81. Parentheses make a very big difference as far as our answer. This one, you're doing the 9 squared first and then putting the negative onto it. This one, you're doing negative 9 times negative 9. Keep that in mind. All right. Next thing I want to talk about is these properties of zero value. I'm kind of write them both down first so we kind of see what we're looking at. I want you to know the difference. All right, so in number 8, 0 is in the numerator and it's being divided by negative 6. In number 9, you have 2 in your numerator and 0 is in the denominator. So this is being divided by 0. Okay, these are two different answers. If the 0 is in the numerator, our answer is just 0. It doesn't matter this sign here. The 0 is neither positive or negative. Okay, but if the 0 is in your denominator, this is called a undefined answer. Okay, so keep that in mind. Undefined. Always will be undefined if 0 is in our denominator. But if it's in the numerator, the answer is 0. Just depends on where our 0 is, what type of answer we're going to get. All right, so number 12. It's actually similar to the example I gave you. What you notice about this, okay, again, this is an order of operation problems. We don't have parentheses, so we're going right to the exponent, and we see the exponent right here. But again, the parentheses are not around the negative sign. So we're going to do 9 squared first, which is 9 times 9, and then we're going to make it negative. So this is going to give me a negative 81 plus 47 divided by negative 2. Okay, we get a negative value here because the negative is not in, we don't have a parentheses here. So then I would always say finish your denominator first. So we have a negative 81 being added to 47. Signs are different, so we're subtracting 81 from 47, and we would get a 34. And then it's negative because there's obviously not more negatives in that 81. So when we get to this point, we have a negative being divided by a negative. Negative over negative gives me a positive. And 34 divided by 2 just gives me a positive 17. Just have a few more examples. 13, you're going to see, it says the product of negative 65 and a number. I just want you to write the equation. What would that look like? Just keep in mind there's keywords here. Product means we're multiplying. And we're taking that negative 65, so obviously we'd write that down. And anytime you see a number, you're going to use a variable. I believe in the instructions of the problem, it says use X for your variable. So really you're doing 65, negative 65 times X. But most of the time you're not going to see a times sign in between a number and a variable. So it's really just going to look like this, negative 6X. This means negative 65 times X there. Okay, and then the only other one you're going to see on 1.7, they throw in a decimal one just to make sure you understand the rules. Sorry, they're both negative. The rules with decimal, and I'm really not, I don't go into the whole how to multiply decimals. I would just tell you use a calculator. You're going to put a 0.3, make it negative, go times 0.7, make it negative, and you're going to get 0.21. You know, you should know it's going to be positive because you have a negative times a negative, and then you'll get your 0.21. Yes, we'll just cover one more real quick. This is another fraction one, but we are dividing. Remember the rule when you're dividing fractions is you change division to a multiplication, and then we flip the following, we flip the following fraction. And what you're going to see here is the 5s would cancel out and the 2s would cancel out. And all you're left with is this little negative sign here. So we don't enter our answer as just a negative. Again, we have a negative times a positive. We need a value. And anytime everything cancels out, that's when you put a 1 there. So the answer to that one is just going to be -1. So there, it's pretty much, I think there's 21 problems, I believe, in that, in 1.7. And those are the examples of pretty much try to do an example of every type of problem you will see.